a physical change. Is a physical change. Okay, I'll tell the example now. What is chemical change? Adam, you tell me.
Chemical change is like when change happens when there is something new.
Yes, very.
Ma'am, like
It is a change if there will be a formation of new substance, right?
like oxidization. No.
If there will be a formation. Oxidization is reversible or not?
No, it can't be
Then
reversed.
it's a chemical change. It's a change if there will be a formation of a new substance. It is known as the chemical changes. Okay, now let me tell you the example of a physical and a chemical change. See, here let me write about the physical change. It's very easy topic. Okay, so those change in which only the physical properties of the substance change, like the sizes, the shapes changes, but no new formation of a substance happen. That's it. Physical change. Okay, in which only what? In which only the physical properties. Like here, if I'm cutting my whole apple into a different sizes, then what's happening? The size of the apple is changing, but the apple remains same, right? It's not like I'm cutting apple and it's mango. No. Right, Adam?
It can't be like that.
Yeah, it's apple only. Only the physical properties, only the size of the apple is changing. Okay, so in which only the physical properties means shape, sizes, only the physical properties of the substance changes. And no new formation. Okay, got it? Everybody got it? What is physical change? That only the physical properties of the substance changes, no new formation happens. And now, what is the next point? In a physical change, the substance do not change their identity. Like here, if apple I'm cutting, apple is not changing their identity to a guava or to a watermelon. No, it's apple only.
Yes, ma'am.
That means the substance do not change their identity. The substance do not change their identity. But there occurs only in the change of some of the physical properties. This your point got, right? Physical property is what? Physical properties is shapes and sizes. Shapes and sizes. Okay, now what's the next point? Just a second. Yes, what is the third point? After the physical change has occurred, the substance can be easily converted back to their original position. Okay, for example, ice. Let's say if ice is there in my freezer, okay, and if my ice is heated, then it's converted into a water. Only the property is ice to a normal water ice, right? But the identity is remains same, that okay, ice is my water only, and the change is reversible. How? If I will keep that water in the freezer, then again it will turn into a ice, right? Razi Shazan?
Yes, ma'am.
Yes. So after means the substance can be easily reversible. The substances can be easily reversed, easily converted back to their original position. Easily converted back to their original position. Adham, what are you doing?
Nothing, ma'am.
Okay, so tell me that how ice is a physical change, Adham.
How ice is a physical change because nothing is lost or gained.
Explain.
Like nothing is gained or lost. Like if you freeze ice,
No, tell me how ice is a reversible change.
You can just like heat it back up and then you can cool it back down. It can be reversed.
It can be reversed. Okay, Shazan, how ice is a reversible change?
Ma'am, because ice is a reversible change, ma'am. Because if you keep it, if you keep the melted ice once again in the freezer, ma'am, then it will again get freeze and ma'am become ice.
Yes, very good. Ice is what? Ice is again converted into a original position. Now, salt solution is also a physical. Is also a physical change. How salt solution is a physical change? Come
Ma'am,
on.
it is solved by evaporation.
Salt solution?
Yes, Shazan. Yeah, Ram?
Salt solution is a physical change because nothing is like lost or gained. When you're making salt, Na and Cl, are there, and after you make salt, still Na and Cl are there.
Okay, but how this salt solution is easily converted into an original position like water
Ma'am,
and yes, Razi.
That I don't know.
ma'am, we can reverse the position of salt
Ma'am,
by
could we
using the
just like,
separating method evaporation.
Yes,
ma'am,
very
yeah,
good.
yeah, we could use the method of like some method of, you know, for separating it.
Yes, the evaporation method will be applied here in the salt solution. For example, this is my beaker, and in my beaker there is a water. Okay, and if I'm putting salt also, the salt solution will be there. So how to how to? This is a salt solution. Now how to separate both the salt and water? What we'll do if we will give heat, then what will happen? Salt will evaporate, right, Aram?
Yes, ma'am.
Will get salt plus water. So this change is easily reversible. I can reverse from salt solution to salt plus water, different, right? So salt solution is also a physical change. Adam, you got this part? Ki how
Yes,
salt
ma'am.
solution is a physical change? Okay. Now, okay, my apple. Apple is also a physical change. Like if I am, let's say this is my apple, and this apple is of 20 gram. Okay, and if I'm cutting one apple from a knife in different sizes, then what will happen? The different sizes, the mass will be conserved. The mass of the different sizes of apple will also be 20 gram. It's not like it's 10 gram or 5 gram. No, mass will be same because I'm cutting one apple into different sizes. If this is 20 and this is 5, it's also a 20, right? Mass is conserved here. Mass is also same in the case of apple, right? Mass is not changing. It's not increasing. It's not decreasing. If I'm cutting an apple, it's not like a mass will change into a 50 gram. No, it will be 20 gram, 20 gram only, right, Razi?
Yes, ma'am.
Yes. Okay. One more example. Can anyone give me? Anybody? Okay. So breaking of a glass. Breaking of a glass is also a physical change. How? If my glass broke, then what will happen? Only the physical property of glass will change.
Yes,
Right?
ma'am. It would be like if you break glass, it will
Ah.
just suddenly turn into water. That will happen.
Yeah. Yes. Very good. If you will break glass, then it will be glass only, right?
It'll be glass only.
Only the physical property of glass is changing. It's changing into a different small pieces, right?
Ma'am, but how is it reversible?
If we can, like, if we collect
Glue?
out what?
Glue?
Yes, glue. It's reversible, right? It's not a chemical change. No new substance is forming if I'm breaking my glass, right, Adam?
Yes, ma'am.
It's not like if I'm breaking, then a new anything like anything. Okay, it's not happening. Only the physical property is changing. One more example I can say: glowing an electric bulb is also a physical change. How this glowing an electric bulb is a physical change, Arham? See, when electric bulb is switched on, the electric current passes through the filament of the bulb, right?
Yes, ma'am.
So during glowing of an electric bulb, no new substance is forming. Only the filament is glowing, right?
Yes, ma'am.
So this is also a physical change. Any
Change.
doubt, Razi, Shazan, and Advika, Arham, in this physical change? Any doubt, anybody?
In the bulb
No,
one,
ma'am.
okay, it's okay, it's okay.
This is a physical change. This is also a
Ma'am,
physical
can I tell some examples of
Yeah.
physical changes?
Yes, sir.
Like crushing a can, melting an ice cube, boiling water, mixing sand and water, breaking a glass, dissolving sugar in water, shredding paper, and chopping wood.
Yeah. Yes, all are physical changes, right?
Aram, which website?
Huh?
I'm asking Aram, which website did you got this?
Examples of physical changes.
Okay. Okay. So let's talk about a chemical change. Okay. Now, what is chemical change?
Chemical change is like something like it's irreversible. If you do it once, you can't do it again.
Yes.
Like burning of a paper is irreversible, it's a chemical change.
What?
Burning of a paper.
Yes. Burning of
Combustion, rust, digestion,
rust is also
photosynthesis,
yes. Rusting of iron is also a chemical change. Burning of
digestion,
paper is also a chemical. Yes. Digestion is also a chemical change.
photosynthesis.
Photosynthesis is also a chemical change.
Ma'am,
Ma'am,
we are learning chemistry, not
ma'am,
biology.
washing your hands?
Washing your hands?
Yeah.
Washing your hands is like how? Yes, it's a chemical change. Yes.
Ma'am, baking?
Breaking, no, breaking of a glass
I'm
is a
not saying breaking, I'm
because-
saying baking. Baking of
Acha, baking, yes, baking is a chemical change because there's a formation of new substance happening, right? Okay, so let's
Yeah.
okay. So those change in which new substance are formed. Those changes in which new substance. So this concept is clear, right, Anam, about the physical, everybody about the physical and
And
chemical
also
change.
like explosion of a firecracker.
This is also a chemical change. Yes, those changes when new substances are formed. And what is the
And
next point?
also like how glow stick works.
What?
Like glow stick, there are two compounds that you mix them together.
So new substance is forming.
Like so it's not reversible.
And then it's a chemical change. If the substance is not reversible, it's a chemical change. If this is substance is reversible, then it's a physical change. Okay. If it can be converted back to their original position, then it's a physical. Now, what is the next point? The original substance lost their identity. Here, original substance is not losing their identity. If I'm cutting an apple, it's an apple only.
Yes, it won't just become water all of a sudden.
Or mango. Yeah. Original substance loses its identity. Lost their identity. Okay, like paper. If I'll burn a paper, it will convert it into a ash, right? Now, so original substance means my paper loses.
Yeah, that's why phoenixes aren't real.
That's why.
Phoenixes aren't real
Yes.
because they rebirth from their ashes.
And here what? The new substance?
The new substance
cannot be
reversed.
Huh.
It's
Cannot
irreversible.
reversed. It's irreversible. Yes. And the last point is this is permanent. Okay, this change is permanent. This change.
So it's like if you want this change to happen, you can only make.
And this change is temporary. This is
Yes.
temporary change.
Yeah.
Okay, this is temporary change and this is physical change. Now let me talk about the examples. What are the examples here
Of
of chemical digestion?
chemical digestion, photosynthesis, washing
Yes.
hands, baking,
Burning,
glow stick,
burning of piece of paper.
glow stick.
Yes. Burning of piece of paper is like when a piece of paper is burned in air with a lighter or with a matchstick. What will happen?
It will
New substance will form. Now, such as carbon dioxide, water vapor, smoke,
smoke and also like
ashes formed.
yes,
In air, what's there? In air, lots of gases is present,
gases are there.
right? Air is a mixture of all the gases. Air is what? It is a mixture of all the gases. Mixture
But
of
there's a lot of gases like
yes.
oxygen, nitrogen, argon, carbon dioxide, neon, helium, and further hydrogen also.
Yes. Air is a mixture of lots of gases. But which gas is useful in burning?
Like oxygen and CO2.
Sure.
Like, oxygen is good for CO2 is like the byproduct.
Yes. Oxygen is useful in burning, right, Shazan?
Yes, ma'am.
Yes. Oxygen is useful.
Like air is mostly made up of like nitrogen, right?
Air is mixture of all gases. Why only nitrogen?
Like mostly nitrogen.
The percentage of nitrogen is yes. Okay. So oxygen is useful in burning. So what will happen? The vapors which is coming out from the candle. Okay. For example, I am burning my candle. So the vapors which is coming out from the candle that reacts with what? Oxygen to form a CO2 and water vapor. The candle which I am burning, my candle will react with oxygen because here oxygen is useful in burning. So my candle will react with oxygen to form a water vapor and H2O. And here water vapor, water vapor and CO2. water vapor and carbon dioxide. Yes, water vapor is H2 only, H2O and CO2. So for combustion, oxygen must be present, right? If we combine, see, if we combine the CO2, the water vapor, the smoke and the ash, then what will happen? Will I able to form a paper again?
No, ma'am.
No? Yes. If I'm combining my CO2, H2O, smoke and ash, I won't be able to, make this paper again. So this changes what? Irreversible.
Irreversible.
Right? Now you got the concept of like how the burning of piece of paper is irreversible. Because if we will burn a paper or will burn a candle, then what will happen? The CO2, water vapor, smoke and ash will form, and air is a mixture of all the gases. Mainly the oxygen is useful for burning. So if I am heating, if I'm burning my candle with the help of anything, then what will happen? The water vapor, CO2, H2O, smoke and ash will form. But if I will combine this whole, then also I won't be able to make my paper again. So this change is irreversible. Only if I'm burning this paper, only the new substance is forming. The original substance here, my paper here, what? Lose their identity, right? It's
Yes, ma'am.
converted into a smoke, ash, carbon dioxide and water vapor. And this change is a permanent change, right? This change is a permanent change. It won't be reversed, right?
Yes, ma'am.
Yes. Shazan, you got it? Adam, Advika and Razi.
Yes, ma'am.
Okay. And Advika?
Yes, ma'am. I got it.
Got it? Okay. So one more example we'll take. Burning of hydrogen in air. Burning of hydrogen is also a chemical change. How when hydrogen is burnt in air or oxygen and
Ma'am, it burns with a pop sound.
yes, it produces a pop sound, right? But this change is not reversed.
It will release what?
Yes,
Ma'am, a pop sound.
A pop sound.
pop sound. But this change is not reversed, right? You can't
Ma'am, it's irreversible. Ma'am, like to burn it, ma'am, you require a lot of heat energy, right?
Yes. But this change is irreversible or reversible?
Well, it's irreversible.
It's irreversible, yes. Burning of a magnesium ribbon.
Magnesium ribbon?
Ribbon. Yeah, let me tell. Okay.
What is
Burning
a
of
magnesium ribbon?
I'll tell. See what is magnesium ribbon. When a magnesium ribbon is heated strongly in oxygen, it burns with dazzling light to form a white powder of magnesium oxide.
Ma'am, can I just search an image?
Search this image, magnesium ribbon. Okay, when a magnesium ribbon is heated strongly with the help of oxygen, because oxygen is very helpful agent in the case of burning, right? So what will happen? It burns with dazzling light to form a what? To form a powder. To form a white powder of magnesium oxide.
Ma'am, I have an image that actually shows it burning.
Show it.
Just wait, let me.
To form a white powder of magnesium oxide. White
Like
powder
there's
of-
like a white light.
This is a video?
No, it's not a video.
Okay, it's an image.
It's an image, but I also have a video.
Okay, show us image.
This is the image. Look, this is the magnesium ribbon. I know, like heated up. So,
Yes, this is a magnesium ribbon and it's heated with the help of what? Oxygen with dazzling light. See here, there's a light, right?
Yes, ma'am.
There's a light.
Yes, ma'am.
White powder of
Ma'am, so it just burns in the middle of the air like that?
yes, which is burned it normally, and it will convert it into a white powder of magnesium oxide. See in the below there is what? There is a paper, and in that paper there is a white powder of magnesium oxide. So this change is not reversible.
Yes,
Right?
and we can't just take the
We
oxide
can't
and just
take this
convert it
white
into a
powder
ribbon.
again to convert it into a magnesium ribbon. No, this change is not reversible. It's an irreversible change. Now, more example: rusting of iron.
Is when rusting of iron is there.
Rusting. My screen is visible.
No, ma'am.
No, ma'am.
If you are, doing, then my screen is not visible. Wait.
Yes, ma'am. It will stop.
It will stop. That day also same thing maybe. And now it will. Yes, now it's visible.
Yes, ma'am.
Okay, yes. So rusting of iron is also a reverse chemical change. How, when iron is exposed to air and moisture for a few days, what will happen? A brown substance will happen in the outer covering of my iron, right?
Yes,
When
ma'am.
my iron will expose to what? Exposed to air and water moisture. Moisture is only a water only. Okay, exposed to air and moisture for a few days, then a brown substance will form. For a copper, there's a green substance will form. So what will happen? This will convert it into a what? Rusting,
Yes,
and
ma'am.
this change is not reversible. We
Yes,
cannot,
ma'am. Definitely not reversible.
definitely not reversible. And where's Advika? She left. Okay.
Yes, ma'am.
So these are the chemical changes and physical changes. Any doubt?
No, ma'am.
No, ma'am.
And Advika
No, ma'am.
leaving is a physical change. She can go back.
Yes. Yes. It's a physical change. Very good. Now the one more topic is left, right? The saturated, unsaturated, and the super saturated. Now, what is where should I write? Let me write.
I
No.
keep on hearing the term saturate, but I don't know what it is.
Okay. I'll tell. What is saturated? Any idea, Shazan?
Keep on hearing it, but I don't know what it
I
means.
forgot I knew it.
Huh?
I know it, but ma'am, I'm not actually
Okay.
able to answer.
Okay.
Ma'am, I keep on hearing it, but I don't know what it means.
Okay. Razi, any idea about this saturated?
Ma'am,
No?
I also knew it, but I am not
Okay.
able to remember.
All three of you know it, but not able to. Okay, I'll tell. Now, what is saturated? See, for example, if there is a class, okay, if there is a class, and in my class, only 30 benches there. How many bench?
30.
30. Okay, only 30 benches there, and in each bench, only one student can sit. How many student can sit?
1.
Only one student can sit in each bench, so there should be only 30 students in my class.
Students, yes.
Yes, right?
Or less.
Yeah, or less. But if I'm like saying if 30 and one can sit, all are present, let's say. Okay. So 30 students will sit in each benches. Now, if 10 more students got admit in my class, let's say 10 more students got admit in my class. Then
Class.
what will happen? Then what will happen?
Ma'am, overcrowding.
Yes, overcrowded. And I won't be able to adjust those 10 students in my class because in my
Ma'am,
class there is only,
won't you have to order 10 more benches?
no, we can't order 10 more benches. We don't have that much of money. Okay. Okay, so 30 students in each bench, only one student. So only 30 students can be there in my
Ma'am,
class.
can you just like take 30 students at a time?
30 students at a
Time.
no.
So like one class for all 30 like for 30 students, another
No,
class for the 10
we can't do this also. We can't do this also. Okay. So see here. So 10 more students got admit in my class. So what will happen? I won't be able to sit those 10 students in my class. So the 30 students is the saturation point of my class. 30 students is what? Is the saturation point.
Oh, okay, I got it. I didn't, okay, got it.
Is the-
I knew I actually remembered this, but I didn't know that I remembered it.
Okay. So 30 student is what? Is the saturation point of my class. Now let's say in a solution, let's say this is my beaker, this is my salt solution. Okay, no, not salt solution. See, it's a solution which cannot dissolve solute beyond. Okay, wait. See, if there's a 100-gram water, okay, and I'm dissolving 1 gram of salt, it will easily be dissolved, right?
Yes, ma'am.
So, but there should be some capacity of water for dissolving a salt. So 100
Yeah.
of water can dissolve only 36 gram of salt.
Yes, ma'am. You can't just like keep. You can't
Adding.
dissolve 100 grams of salt and 100 grams
Yes,
of
we
water.
can't do that.
That won't work.
Yes, only 30 gram of salt can dissolve. Sorry, 30 gram of water can dissolve only 36 gram of salt. So what will happen? But if, let's say, if I'm adding 1 gram of salt more to my this salt solution, then what will happen?
It will not be able to dissolve.
It will not dissolve, and salt will come in this down, and it will settle down, right?
Yes, ma'am. Ma'am, only 1 gram of salt will settle down, or like a more?
Only 1 gram of salt will settle down because this is the extra salt, right? Because 100 gram of salt water is easily dissolving only 36 gram of salt. If I am adding 0.5 gram also, then also it will
settle down, but it will be very less.
So
Ma'am, like, if you add 100 grams of salt, you'll like 664 left.
So what I'm trying to say here is this is what this will become a saturated solution. And what is a saturated solution?
And you can't put any more salt in.
Saturated solution are those solutions which will not accept 1 gram or 0.5 gram of salt or anything in the solution. Okay. Here in my class also only 30 students can sit. This is the
Yeah, and like in 100 grams of water only like 36 grams of salt
is the
can be.
saturation point of my salt solution. This is the what we can
Ma'am.
say.
Ma'am,
Yes.
basically, this is the stage where water cannot dissolve more salt.
This is the stage where water cannot dissolve more salt. This is the stage where I won't be like here in my class only 30 students can sit, 10 more students can't sit. This is the saturation point. Here is the saturation point is 30 gram, only 36 gram of salt is the saturation point. If undissolved, see, if let's say this is my undissolved salt. If this undissolved salt wants to dissolve in water, then is there any way? If this undissolved salt wants to dissolve in water, is there any way?
I don't
Yes,
think
ma'am,
so.
we can add more water in the glass.
Yeah, we can't add more water because the saturation point is this only. We can't do that. What we will do? Yes, there is a way. How there's a way? There's a way like the dissolved particles will come down and the undissolved will dissolve. Okay, see here. There's a dissolved particle and here's a undissolved salt. Okay.
So the dissolved particles will take the place of the undissolved particles.
And the undissolved particle will take the place of the dissolved particle. So that's how there's a way that okay, the settled salt can dissolve in water, right?
Same thing happens for sugar, right?
Same things happen for sugar.
Okay, that's why my sugar wasn't mixing in my water so well.
Okay. So Razi, you got this? How there's a way that undissolved salt dissolved in water? Because
Yes, ma'am.
dissolved salt will take place of an undissolved salt, and undissolved salt will easily dissolve in water. But the saturation point is this only. 100 gram of water can only dissolve this 36 gram of salt. If I'm adding 0.5 also, then also it won't will happen. Only it will get settled down. This is the saturated point, yeah, saturated solution, we can say. Right? Now you understood what is a saturated solution?
Yes, ma'am.
Sure. What is a saturated solution, Shazan? Shazan, what is a saturated solution? What is saturated? What is saturated point? Razi?
Ma'am, saturated solution in which limited amount of salt can be mixed.
Okay. Razi?
Ma'am, saturation point is the stage where we cannot add more salt in water or any solvent.
Yes. Because this is in 100 gram of water, only 36 gram of salt can be dissolved. Not more. Yes, sir.
Ma'am, for 100 grams of water, how many grams of sugar can be there?
Now you can like calculate it.
Okay, then.
Okay. So this you got the saturated point. The saturated point means what is saturated point, Arham? Means we are not.
Saturated point is like when it is when like when like you have like in 100 grams of water you can only have like 36 grams of salt and no more else. If there are more, it will settle down, but if you try to mix to settle down which are dissolved, whatever is like if you try to mix up it more, try to make that dissolve, the particles that are undissolved will take the place of the particles that are dissolved, and the particles that are dissolved will take the place of the undissolved.
So now you got it. Saturated solution means if there is means the capacity is not there to add more students in the example of this class, and here the capacity.
Otherwise, you have to make them stand.
Otherwise, we have to make stand or sit in the floor.
Yes.
But this is the capacity.
But you can change the students who sit.
We can change. Yes, we can do this. But the capacity is only 30 students can sit in each bench. And here the capacity is only 30 gram of salt can dissolve in 100 gram. If one more is also 0.5 is also extra, we won't be able to do this, because the saturation point is only 30 gram of salt. Now we will talk about the unsaturated solution, but it's already 6:45. Now what to do?
Something.
What something? So this topic I'll explain in the next class.
Okay, ma'am.
Next class, unsaturated and saturated, then test of this chapter.
Yay. Ma'am, you also have to talk about super saturated, right?
Unsaturated and supersaturated, both topics. Okay.
Okay, ma'am.
So you got physical, chemical, and saturated, right? Everything is clear, no doubt.
No, ma'am. I have
Razi,
no doubt.
Shazan? No? Okay. Shazan, any doubt?
No, ma'am.
Okay.
Well, bye, ma'am.
What?
No, ma'am. That's it. Thank you.
Okay. No doubt. Okay. Thank you.
Bye, ma'am. Thank you, ma'am.